Good morning to one and all. Today I am presenting pneumatic air muscles. Air muscles. The objective of these pneumatic air muscles is motion and actuation, force generation, flexibility and adaptability, precise control and energy efficient, and safety and compact design and biomechanical and robotics and automations. The introduction for pneumatic air muscles is the robots came significant to serve and assist humans, especially for older peoples and disabled people. However, the high rigidity of robot joints will to be hazardous to the human because of human has soft arms and compliance joints. This achieved by numerous muscles. The necessary of human-like actuator system may research have uh, motivated to study in this field and create the pneumatic artificial muscles. The pneumatic artificial muscle is used for converting pneumatic power to pulling artificial muscles. The pulling force and eventually causing movement of the mechanism. The PMA is used for larger demonstration as muscles and pneumatic as its source of a- activation force. The membrane thought to have to capacity to enter radially stretch or alternately its radially sections. History of this is invented by McCabe air muscle. McCabe. The air muscles were in in is introduced for orthotics in 1950s. They have the advantages of being lightweight, easy to fabricate, and are self-limiting and have load length curve similar to the human muscles. The source of inspiration was the human itself, which would swell where a force has to be applied. They were developed for us as an ortho appliance for polio patients. The working of this are pneumatic air muscles. The air muscles have performed characteristics very similar to the human muscles. The force exceeded or decreased as the muscles contract. This is due to changing inner wave angle of braced mesh as the muscle contract. As these muscles contract as the mesh, the expand radially is scissor-like motions. It exert less force due to the wave angle become eh, ingre- incredibly shallow. As the muscles contract, the gas law states that if you increase the pressure, you also increase the volume of the expandability of cylinder. The expanding volume of the bladder is ultimately constrained by a physical properties of bladder mesh sleeve. So, in order to create a great pull, the parts of the pneumatic air muscles are outer sheet. The outer sheet is a flexible tubular converting the enclosed the other components of the pneumatic air muscles. It is provide a protective and durable layer that can expand or contract as this in internal bladder is inflated or deflated. Bladder or tube. Inside the outer sheet, there is a bladder or tube. This connects a contain compressed air or gas, and key element is responsible to the expansion and contraction of the air. Count of the air. The muscles. The bladder is typically made up of material that can be withstand the pressure change and maintain the flexibility. And the connectors. At the both end of the pneumatic air muscles, there are connectors that also for the muscles to be attached to the other component structures. Air in inlet and outlet. One of the end connectors usually that one on the inlet side serve as the point where compressed air or gas is introduced into the muscles or removed from it. This inlet and outlet essential for controlling the pressure inside the bladder, which into turns regulate the expansion and contraction of the muscles. Control system. In many applications of especially in robotics and automations, a control system is employed to manage the air pressure with pneumatic air muscles. This control system can be precise adjust in air pressure, allowing the actuators to control the muscles motion and force generation. This advantage is lightweight. The lightweight. The pneumatic air muscles are typically lightweight, making them suitable for applications where minimizing the weight is essentially such as in robotics and aerospace. Compact designs. They have compact designs allowing them to easily integrate into tight space and structure within limited room for traditional actuators. High force to high weight ratio. The pneumatic air muscles can generate significant force relative to the weight, making them suitable for application that required storage yet lightweight and actuation. Precise control. By adjusting the air pressure, you can achieve precise control over motion and force generation by pneumatic air, which is advantages is applied applications where and accuracy in critical. This disadvantage of pneumatic air muscles is heat generation. The compressed and expansion air with the muscles can generate can generate heat which cannot be suitable for applications sensitive to temperature change. Noise. The pneumatic system can be noisy due to released compressed air in quiet or noise sensitive environment. The additional sound damping measure may can be required. Inefficient of energy storage. While the pneumatic air muscles can store and release energy efficiently, they are less efficient to store energy over expand period. The compressed to creating other energy storage system. Limited load carrying capacity. The pneumatic air muscles are not well suitable for application required extremely high loads, as their capacity is limited. The compressed to some hydraulic or mechanical systems. Applications. The pneumatic air muscles are applied into humanoid robots, prosthetic limbs, lower body exoskeleton, and FM motion seats. Conclusion. In this present studies, the compatibility of braced mesh shell with bladder has been inflated in uniform and non-uniform conditions. The researchers effect were important to the new development of PAM to provide an optional for load lifting mechanism while possessing the safety, probability, the reliability, and low cost. The extremely result to show that effectiveness of value of mesh suitably. This experiment contributes knowledge on of PMA and mechanisms, as well as assisting by avoiding the failures of PMA. During the pneumatic air muscle contract process, the future recommends for this project is to increase the thickness of the bladder, as well if the tube thickness is high, it can withstand more pressure applied. The based on that, the type of breast can be recommended for better efficient of pneumatic air muscles. Thank you for listening my presentation to one and all. Thank you for listening to my presentation.